Alright, here we have Regents Review number 9. So question number 1 says Sam and Jeremy have ages that are consecutive odd integers. So remember, if we're talking about odd, that's like 1, 3, 5, 7. So in order to get to each one, we would have to add 2. 3 plus 2 is 5, 5 plus 2 is 7. So when we have consecutive odd integers, we always write let statements. So the first one is always going to be x. In this case, they asked us to use j. The second one would then be j plus 2, because we said we're going to add 2 to each side each time. So the product means that we have to multiply. It says the product of their ages is 783. So j times the second one equals 783. If we distribute, j times j is j squared, 2 times j is 2j, equals 783, and that should match with choice 3. Question number 2, we're asked to solve for x. If you try to convert 5, 6 to a decimal, it's going to be a repeating decimal, so instead we'll just have our calculator do the work for us. We want to try to get x alone, so I have to minus 1/2 to both sides. And I'm going to make my calculator do that. So in my calculator, I'm going to do parentheses, 5 divided by 6, close the parenthesis, minus parenthesis 1 divided by 2, close the parenthesis. The calculator is going to give us 0.33333333. If I math enter it, it gives us 1/3. So now, in order to get rid of the 3 on the bottom, that's multiplying, so we undo that's division, so we undo division by multiplying. So I'm going to multiply 3 to both sides. These cancel out, and we're left with 2x equals 1. One more step, divide both sides by 2. 1 divided by 2 is 0.5, or you could math enter it and get 1/2. Question number 3 asks us to graph this line. In order to graph the line, though, we have to have it set equal to y. So the first thing I'm going to do is add 6x to both sides. So I have 3y equals, now remember, we're trying to make it look like y equals mx plus b. So I have to put my x stuff first. So my x stuff is 6x and then plus 3. Now I'm going to divide everything by 3. 6 divided by 3 is 2. Put my x on there. 3 divided by 3 is 1. Now that I have y alone, I can get my slope and my y-intercept. My slope is in front of the x. It's 2. I can always put a 1 under it to make a fraction. And my y-intercept is this plain number. We always start on our b, that's our beginning. It's called the y-intercept, so we start on our y-axis. So I'm going up to 1 and putting my first dot. From there, I'm going to count up 2 and write 1. So up 2 and write 1, up 2 and write 1. To get the points to go in the other direction, we go down 2 and left 1, down 2 and left 1, down 2 and left 1, down 2 left 1, down 2 left 1. I'm going to connect my points, and then I'm going to remember that it is a line, so I have to make sure I put arrows on it. And let's just not forget to label our line. All right, question number 4 asks us to write the equation of the line below. Well, you're going to need the two things we just found in the previous question. We need m and b. B is where the line begins, on the y-axis. So here's our y-axis. You can look. It's hitting right there. So our b is -2. It already has our dots. So from this dot to this dot, I would count up 1, 2, 3, and over 1. So my slope is 3 over 1. Just like in number 3, remember we're trying to get it to look like y equals mx plus b. So now I know my m, now I know my b. Y equals 3x minus 2. And there's our equation of the line. Question number 5 gives us a table, shows the cost of mailing a postcard in different years. It wants to know which time interval did the cost increase at the greatest average rate. That, you should know, means slope. And we know a slope formula, m equals y2 minus y1 over x2 minus x1. So this is a multiple choice question, but we're not going to guess. We just have to calculate 4 slopes and find out which one is the greatest. So choice number 1 says to go from 1898 to 1971. So I'm going to label this. This is my x1, this is my x2, this is my y1, and this is my y2. So now I'm going to use my slope formula. So 6 minus 1 over 1971 minus 1898. When I subtract, it's 5 over 73. Let's make it be a decimal. So 5 divided by 73, it's going to be a really long decimal. I'll round it, 0.07. Now we have to try choice number 2. Choice number 2 tells us to go from 1971 to 1985. So x1, x2, y1, y2. So 14 minus 6 over 1985 minus 1971. When I subtract, I get 8 over 14. Let's divide and round, and you should get 0.57. All right, question number 3 says that we have to go now from 1985 to 2006. So I'm using this one right here. So here's my x1 and my x2, my y1 and my y2. Let's do our subtraction problem. 24 minus 14 over 2006 minus 1985. When I subtract, I get 10 over 21, which if I divide 10 by 21 and round it, looks like it's 0.48. The last one then says that we need to use from 2006 to 2012. So here's my x1, here's my x2, here's my y1, here's my y2. So my last subtraction problem, 35 minus 24 over 2012 minus 2006. When I subtract, I get 11 over 6. When I divide that, I get 1.83. So of these 4 slopes, the one that is the largest is 1.83. So that matches with choice number 4. And we have one more on the back. So this question is about Craig driving to meet his friend in another state. So in the course of his travels, he encountered both highway and city driving. Based on the graph, during which interval did Craig most likely drive in the city? So we have 4 intervals. We have from A to B, and you can see his speed is definitely increasing. But from B to C, he didn't travel any miles at all, but time went on. That means that he was stopped here. Then in the next interval, his speed starts increasing quite a bit, or his miles traveled starts increasing quite a bit. So it looks like he's driving back on the highway again. This one was also highway driving because his miles are increasing rapidly. The last interval, though, it still is increasing, but you see how this one is not increasing quite as high as the green one and the red one? So that must mean that he's most likely driving in this city. And his miles are still increasing, but not as quickly. So it was probably because of traffic. So we'll say from interval D to C, because his distance was increasing, but not as quickly. and that could be due to traffic or red lights. So we'll just say because of traffic. On the highway, you don't have to worry about red lights, and if someone's in your way, you can usually change lanes and go around them. All right, part 2, explain what might have happened in the interval from B to C. So we kind of already talked about that. That's a flat spot, so that means he stopped. So if you're going on a long trip to your friend's house in another state and you're driving, maybe he stopped to eat. Maybe he got a flat tire. Maybe he just stopped to take a rest. Whatever you write here, you just have to make sure you're saying that he's stopped. The last question says, determine Craig's average speed to the nearest tenth of a mile per hour for the entire trip. This right here should clue you in to the word slope. We talked about it earlier on here. y2 minus y1 over x2 minus x1. We're just going to have to go to the graph and get the points. It says for his entire trip. So we start down here, which would be the point 0, 0. And his trip ends way up here. This would be the point 7, and if I follow this over here, 230. So here's my x1 and my y1. Here's my x2 and my y2. So my subtraction problem, 230 minus 0 over 7 minus 0. That gives us 230 over 7. It asks us to round it to the nearest tenth. So 230 divided by 7 is 32.9. And that is Regents Review number 9.